In April 2025, a research team pointed the most powerful telescope ever built at a planet 124 light-years away and found something in its atmosphere that, on Earth, only comes from one source: life. For a few months, headlines everywhere said the same thing, in different words: we might not be alone anymore. By August, that evidence was gone, not disproven, not explained, just gone, dissolved back into statistical noise, the way almost every hopeful signal from space has dissolved before it. You'd think that would be the worst kind of disappointment, a door that opened for a second, then quietly closed. It might be something much worse than that, because there's a theory built by economists, physicists, and philosophers, not science fiction writers, that says finding life out there wouldn't be good news at all. It would be one of the most terrifying discoveries humanity could ever make. And the closer you look at the silence we've been listening to for 70 years, the less it looks like an empty universe, and the more it starts to look like a warning. Tonight, we climb the exact staircase every form of life in this universe has to survive. We watch two of humanity's closest brushes with contact fall apart in real time, and we end with the one question almost no scientist wants to answer out loud: is the filter behind us, or is it still coming? Before we go further, answer this honestly, right now, in your head. If tonight, for certain, we learned we are completely alone in this universe, would that make you feel safer, or would it feel like something's missing? Hold on to your answer. By the end of this video, it might have changed. Here's what most people assume about space: that it's busy, that somewhere out there, across billions of galaxies, someone is broadcasting, building, expanding, living a life we simply haven't found yet. The math seems to back that up. Our galaxy alone holds close to 400 billion stars. Count them one by one star per second, and you'd still be counting 12,000 years from now. And that's just our galaxy. There are hundreds of billions more beyond it. Now translate that into time instead of numbers. Many of those stars are billions of years older than our sun. If even one civilization on one planet around one of those ancient stars had figured out slow interstellar travel, nothing exotic, no faster than light physics, just steady, patient expansion, it would only need a few million years to spread across the entire galaxy. On a cosmic clock, a few million years barely registers. So the universe has had the time. It has had the material. It has had almost unimaginable opportunity. And when we point our instruments outward and listen, we hear nothing. In the summer of 1950, a physicist named Enrico Fermi, one of the men who built the first nuclear reactor, one of the minds behind the atomic bomb, was walking to lunch at Los Alamos with 3 colleagues. They'd been joking about flying saucers. Sitting down to eat, in the middle of a completely different conversation, Fermi suddenly asked a question that had nothing to do with what anyone was discussing. "Where is everybody?" His colleagues laughed because somehow, without him explaining, all of them instantly understood exactly what he meant. He never wrote the question down. He never published a paper on it. He died 4 years later, and yet that single sentence, asked by a man who helped invent one of the most destructive weapons in human history, became one of the most haunting open questions in modern science. 75 years later, we still don't have an answer. But here's the part that should actually unsettle you. The silence itself isn't neutral. It isn't just we haven't found anything yet. Given how much time and how many opportunities the universe has had, the silence is strange. It's a result that needs an explanation. In 1996, one man proposed an explanation so simple and so cold that it's kept astrobiologists awake ever since. He wasn't even an astronomer. He was an economist. His name was Robin Hanson, and the idea he put on paper has a name today that sounds almost too small for what it actually implies: the Great Filter. Picture the journey from dead matter to a civilization capable of reaching the stars as a staircase. 9 steps. Every form of life in this universe, anywhere, on any planet, around any star, has to climb it in order to become what we are right now, a species capable of asking whether it's alone. Step 1. The right kind of star. Sounds easy until you learn most stars in the galaxy are small, dim red dwarfs that blast their orbiting planets with radiation intense enough to strip away atmospheres before life ever gets a foothold. Most real estate in this universe is unlivable before the story even starts. Step 2. Abiogenesis. The moment dead chemistry becomes something that copies itself. This step hides a small, brutal paradox. DNA needs proteins to replicate. Proteins need DNA to know how to form. Neither one works without the other already existing. Somewhere on this planet, roughly 4 billion years ago, that circular impossibility solved itself anyway. We don't fully understand how. We only know it happened once. As far as we can prove, life gets slightly more complex, and then it stops. For 2 billion years. Not 2 billion years of nothing happening. 2 billion years of bacteria. Simple, single cells doing the same basic chemistry, generation after generation, so long that if you compress the entire history of Earth into a single 24-hour day, life would spend from midnight until nearly 4 in the afternoon as nothing more than floating microbial film. Then, in what looks like an accident, one primitive cell swallowed another. Instead of digesting it, something strange happened. They merged. One provided shelter, the other provided energy, more energy than any single cell had ever had access to before. That accidental partnership, as far as we can tell, happened exactly once in the entire history of life on Earth. Every animal on this planet, every fish, every bird, every human being hearing this right now is a direct descendant of that one accident. So maybe that's the filter. Maybe complex life is the impossible step, and the galaxy is quietly full of planets that never got past being covered in bacterial film. That would actually be good news. It would mean the filter is behind us, already survived, already paid for. But there's a second possibility, and it's the one that should make your stomach drop. What if we haven't reached the filter yet at all? Remember that discovery we opened with, the one that made headlines in April 2025 and quietly disappeared by August? We're not done with it, because what happened to that evidence isn't just a footnote in an astronomy article. It's a pattern, and once you see the pattern, you can't unsee it. Quick question, and I want you to actually answer this one in the comments before we go further. Out of everything on that staircase, the right star, the origin of life, the leap to complex cells, or the leap to real intelligence, which one do you think is the impossible step? Lock in your guess. What comes next might change your answer. Here's the detail that changes how urgent this whole question actually is. The universe is roughly 13.8 billion years old. That sounds ancient. It isn't, not compared to how long it's going to exist. The average small star will keep burning for over 5 trillion years. Plot every possible moment a civilization could arise across the full lifespan of the universe. Pick one at random, and you'd almost certainly land somewhere near the very end of that timeline, trillions of years from now, not 14 billion years in. We are absurdly, statistically early. Sit with that for a second, because it's not a comforting kind of early. It's the kind of early that needs an explanation. In 2021, Robin Hanson, the same economist who first described the Great Filter, came back with a new model, built alongside 3 other researchers, to explain exactly this. They called it the Grabby Aliens Hypothesis. The idea, somewhere out there, certain civilizations don't stay quiet. They expand, fast, close to the speed of light, and wherever they go, they leave visible, permanent fingerprints. Once enough of them exist, they start occupying the universe so completely that no new civilization can ever get started again. Every habitable world gets claimed before life on it has the chance to become anyone. If that's true, it explains why we exist this early. We're not lucky, we're not special. We simply exist in the last remaining window before that expansion reaches us and closes the door for good. According to the model's own numbers, that window has an expiration date, somewhere between 200 million and 2 billion years from now. On a human scale, that sounds unimaginably distant, almost meaningless. But that's not actually the disturbing part. The disturbing part is the reason we still can't see any of these expanding civilizations anywhere in the sky. If they moved slowly, we'd probably have spotted early evidence by now. Some trace, some structure, some anomaly. The fact that we see nothing at all means one of two things. Either they don't exist, or they move so unbelievably fast and so recently that the only ones we could ever detect are the ones close enough to already be arriving. In other words, the silence isn't proof that we're safe. The silence might be proof that if something is coming, we'd see it right before it got here, not years in advance. And that's assuming the threat is even coming from outside at all. There's another explanation for the silence, one that doesn't require every other civilization to be dead, or unlucky, or stuck on a staircase they can't finish climbing. What if they're not silent because they're gone? What if they're silent because silence is the only thing keeping them alive? Picture a forest at night, not a peaceful one where every sound could be the last sound you make. In that forest, you don't know who else is out there. You don't know if they're hunters or prey. You don't know if friendly is even a concept that survives contact between two species that evolved on opposite sides of the galaxy with nothing in common except the drive to keep existing. In a forest like that, the only rational move is silence. Don't call out. Don't light a fire. Don't reveal exactly where you are, because the one thing you can never know for certain is what's listening and what it does the moment it hears you. This is the dark forest hypothesis, and it flips the entire question upside down. It's not that the universe is empty. It might be that the universe learned a long time ago that revealing yourself is a death sentence, and every civilization smart enough to survive long enough to notice that goes quiet. Here's the part I need you to actually sit with, not just hear. We haven't stayed quiet. Every television broadcast, every radio transmission, 70 years of accidental electromagnetic noise has been leaking off this planet since the 1930s, expanding outward in every direction at the speed of light. A growing bubble, roughly 90 light years wide right now, announcing exactly where we are to anything close enough to be listening. We've been shouting into a forest we don't understand the rules of. And if the dark forest is real, the question was never, is anyone out there? The question is, who already heard us? And what have they decided to do about it? Here's where this video has to change direction, because up until now, every threat we've talked about has come from somewhere else, some other civilization, some cosmic deadline, some unknown listener in the dark. But the most credible version of the Great Filter isn't out there at all. It's in here. In 2020, an Oxford philosopher named Toby Ord spent over a decade calculating something most people never let themselves calculate calculate the actual odds that human civilization collapses within this century, not in some distant science fiction future. This century, possibly your lifetime. His number, roughly 1 in 6. Take a revolver, put one bullet in the chamber, spin it, point it at the next 100 years of human civilization, and pull the trigger. That's the risk Ord calculated. From nuclear war, engineered pandemics, and artificial intelligence, we're building faster than we understand it. For comparison, across the entire 20th century, 2 world wars, the Cold War, the closest the planet ever came to nuclear annihilation during the Cuban Missile Crisis, that same risk was estimated at roughly 1 in 100. The danger didn't shrink as we got smarter. It grew 16 times higher in a single century. Why would a species this intelligent walk willingly toward its own filter? Because intelligence was never the thing that was supposed to save us. Think about what it actually takes for a species to become powerful enough to leave its own planet. It needs to control staggering amounts of energy, and any species that can command that much energy can, by definition, also turn it into staggering amounts of destruction. The same fire that could carry us to the stars is, on the way there, more than capable of burning everything down first. And here's the part that has nothing to do with aliens, nothing to do with distant stars, and everything to do with the world you're living in right now. Imagine 2 nations, each capable of building a weapon dangerous enough to end civilization. Neither trusts the other completely. If one disarms and the other doesn't, the one that disarmed loses everything. So neither disarms. Both keep building. Both keep escalating. Not because either one wants catastrophe, but because the logic of the situation makes cooperation nearly impossible, even when everyone involved can see exactly where the road leads. This isn't a hypothetical. This is the actual, documented structure of nuclear policy, and it's starting to repeat itself with artificial intelligence. Different technology, exact same trap. There's a name researchers use for this pattern: the Titanic effect. Every system on board reads normal. Every gauge is stable. Everyone on deck is comfortable, confident, celebrating how smooth the crossing has been. And the entire time, the ship never slows down, because slowing down was never part of the plan. Here's the sentence that should actually stay with you. For humanity to make it out of this century intact, we don't just need to make good decisions. We need to make the correct decision on every dangerous technology we invent, every time, forever. The filter only needs one mistake, one lab accident, one miscalculated escalation, one system we built to help us that decides, quietly and without malice, that helping us doesn't require asking us first. We need to be right always. The filter only needs to be right once. Now go back to April 2025. That planet, 124 light years away. The molecule that on Earth only comes from living things. The headlines, the hope. By the time independent scientists re-examined the exact same data, the signal that had made front-page news around the world had quietly become something else. Statistical noise, indistinguishable from ordinary chemistry, dressed up by hope and a small margin of error into something it was never actually confirmed to be. This wasn't the first time. In 2020, a possible biosignature on Venus made headlines and unraveled the same way. In 1996, scientists believed they'd found fossilized bacteria inside a meteorite from Mars, treated as historic for years, before the evidence quietly fell apart too. Every single time, for a moment, we thought we'd found the answer to Fermi's question. Every single time, the universe took it back. Maybe that's not a coincidence. Maybe that's the pattern the universe has been showing us for 70 years. Not silence, not emptiness, but something closer to a graveyard, where every headstone briefly looks, for just a second, like it might still be breathing. So, is the filter behind us or still ahead? The honest answer, nobody knows. Not Robin Hanson, not Toby Ord, not the researchers at Cambridge who thought for 4 months in 2025 that they'd changed history. But here's what the evidence keeps quietly suggesting. From every direction we look tonight, the steps behind us look survivable. Hard, rare, but survivable, because we're proof it can be done. The steps ahead of us are the ones piling up the bodies, not metaphorical ones, real ones, in every corner of the galaxy where the lights should be on and aren't. So think about that revolver again, 1 in 6. Now ask yourself honestly, not what you hope, what you actually believe. Do you think the filter already started? Quietly, recently, sometime in your own lifetime, without anyone announcing it? Type your answer. I actually want to know. Maybe the reason the sky is silent was never about distance or luck or the odds of complex cells forming twice. Maybe every civilization that ever asked Fermi's question got exactly as far as we have right now, right up to the point of understanding the danger clearly enough to be afraid of it. And that fear arrived one step too late to change anything. We don't know which side of the filter we're standing on. We just know we're standing on it right now. Where is everybody? Maybe the more honest question, the one Fermi never got to ask, is how many of them got exactly this far and stopped? If this changed the way you look at the night sky, even a little, that's exactly what the like button is for. And if you want to keep walking further into the dark with me, subscribe, because the next question isn't whether someone's out there, it's whether they already found us.